Hi, the purpose of this presentation is to introduce you to the book Universal Currency, The Path to Fair Trade and Real Money. Now you are watching part 2. Thank you for tuning in. The target audience for this presentation is everyone who uses currency, including ordinary people, policymakers, and economists. If you have not watched part 1, I strongly encourage you to watch it as it serves as an important introduction to part 2. In part 2, we will discuss what is the correct way of creating currency. However, before we start discussing the universal currency model, we find it useful to highlight certain aspects of bartering. Consider the case of Peter and John. Peter has apples and John has oranges. In their prefrontal cortex, they assign a value for their product. Their assessment could be subjective or objective. Subjectively, they concurred that both apples and oranges are delicious fruits. Objectively, they estimated that it requires about the same amount of time and effort to cultivate and harvest these fruits. So they're about equivalent in value. And since Peter wanted oranges and John wanted apples, they could simply exchange these products. So what just happened here highlights three fundamental aspects of bartering. One, the transaction is direct exchange of value, where no currency is used or created. Two, the transaction is transparent, not obscured by a currency with unclear or uncertain value. And three, there was a consensus of value between these two individuals. The consensus on value is a very important attribute in this form of exchange, and we will be referring to it later in our discussion on value. We will discover how we can find a consensus on value on many other products with the entire population being involved, not just with two people. We will evaluate a system where you use currency for transactions while keeping in mind how the same transaction would have been executed had it been through bartering. Let's consider a little more complicated example. Here you have Peter and Mary. Peter has 20 apples and Mary has nothing, but she offers Peter a jar of apple jam in exchange for his 20 apples. The jam is a more complex product than the primary product, which is apples. Peter agrees and the exchange takes place. Now, unlike the previous example with Peter and John, where the apple was equivalent to the orange, here the jar of apple is not equivalent to the 20 apples. Mary just needed 10 apples to make a jar of jam, and the remaining 10 were her profit. Now, Mary can keep these 10 apples or trade them for corn with someone else, or she can make another jar of jam and sell it to someone else in exchange for a hammer. Delta apple, which is the total apple minus Mary's cost, is 10, which is Mary's profit, and it represents a measurement of the added value that Mary created with her more complex product, which is in turn a measurement of the value of the energy that Mary put to make the jam. Note that all value originates from primary production, including the apparent added value. Without the primary products, that is those 20 apples, there would have been no value at all. You may say, okay, this is basic early human economics, but how is it relevant to modern advanced economies and complex trade? Let's find that out in the next example. This last example demonstrates a much more complex form of barter trade that is actually very relevant to modern economies. Consider the case of Peter, who has metal, John has plastic, Mary has rubber, and Steve has paint. And Ford has nothing. However, Ford offers to make a car for each one of these primary product makers in exchange for their products. For simplification purposes, we will assume that a car is made only of these four components, where A represents metal, B represents plastic, C represents rubber, and D represents paint, and Z represents the car. In order to make four cars, one for each primary producer, Ford will need 4 times the amount of product. But in this case, he will make no profit. Therefore, he asked for 5 times the amount of products to make 5 cars. So he can give one car to each one of these producers, and he gets to keep one car as his profit. Here, delta is the total number of cars made minus the cars he needed to give to his suppliers. And 1z would be his profit, which also represents the added value that he created by making this complex product. Note that the profit, or the presumed added value, is variable, as Ford could have negotiated better terms, and maybe his delta z was 3 cars instead of 1. Delta z must always be greater than 0, otherwise it's not economically feasible to produce this complex product unless you are using slaves or volunteers. The upper limit of delta is dictated by the profitability of primary production. So delta z may be 6 or 10, but it cannot be unlimited. Again, you can notice that all value comes from our primary production, including the presumed added value. An important thing to remember is that a complex product does not necessarily have more added value than its individual components. In many cases, and for many people, a car may be of more added value than just having plastic or metal, but not for everyone. For example, someone living in a rugged mountain terrain, such as a Sherpa Sherpa in the Himalayas, the car may be useless. One of its individual components, such as metal to make pickaxes and shovels, has more value to him. This example we just presented applies to any complex product, be it a computer, a spaceship, or anything else. It is important to keep in mind what we have discussed earlier while exploring our universal currency model. The question is there a correct way to create currency? And the answer is yes. So how do we do that? One, we have to understand what is the origin of all value. As we have established in the last few slides, primary products are the origin of all value. We will also make this point very clear in the next two slides. Two, we have to create a system where there is consensus on the value for a specific primary product. Three, we have to disburse with a B currency when you create value. Four, you have to disperse with a P currency when you circulate value. Five, you have to eliminate currency when you consume value. Six, you have to define the unit of account properly. And seven, you have to apply the system globally as a universal currency. A universal currency levels the playing field for all producers across the planet to compete fair and square. So what's happening here? Inside those leaves is a production factory, the largest and most important production factory on Earth. The energy of the sun is converted into a chemical energy known as adenosine triphosphate, or ATP, which is a universal currency that the entire biological ecosystem uses to perform any work. Nothing would exist on Earth without that energy. No plants, no animals, and thus no human economy without it. Everything is dependent on it. ATP is the energy, which is the currency that living things use to pay for work done inside the cells, the factories of life. This is how forests and meadows come into existence. Let's enlarge this picture a little bit. You can see here the sun, which is providing energy to the plants so they can grow and multiply. And this energy is transferred to the deer, which feeds on them. In turn, the energy is transferred to the mountain lions, which feeds on the deer. And finally, the energy is transferred to the decomposers, which feed on all of them. Classically, we think of plants as producers, herbivores as consumers, carnivores as consumers, and decomposers as consumers. But if you think about it more carefully, you can consider plants as primary producers because they produce the primary product in the economy. You can think of herbivores as secondary producers because they produce the meat for the mountain lion, which is also a tertiary producer in the economy because it also produces energy to the decomposers, which are the final consumers. So as you can observe, it all starts with plants, and there is no economy without them. They will not grow and multiply without the energy from the sun, and in turn, no animals can exist, grow, or multiply without feeding on them. All living things exist because of the energy transferred from primary producers. You can see how nature clearly gave the answer of how to correctly create a currency. The answer is in plain sight. The only thing that needs to be done is to issue new currency to primary producers, and this will power the rest of the economy. So in our human economy, we can replace the sun with a system of value which disburses currency to the primary producers, as we can see in the next few slides. Let's focus now on the human economy. In this ecosystem, we have also primary producers, such as iron miners. We have secondary producers, such as pipe makers. And we have tertiary producers, such as plumbers. Note that the pipe maker would not have existed in the economy without the iron miner, and the plumber would not have existed in the economy if there were no pipes and wrenches so he can do his job. We also have consumers of primary, secondary, and tertiary products, for example, a homeowner. So how do we correctly create a currency so that the constituents of this economy can use to transfer their energy? We will create a system of value, SOV, which issues currency, value, to the primary producer in the economy, just like the sun was giving currency only to the primary producer, in that case was the plants, and that currency, that energy was transferred in the ecosystem from there. Here, the primary producer is also a consumer of other products in the economy, and the consumer, the homeowner, is also a producer For example, he could be a baker. And the secondary producer, tertiary producers are also consumers, just like the primary producers, so they can buy, for example, bread from that baker, and the currency that was issued initially to the primary producer will be circulating in the economy. Let's demonstrate how the system of value works. The system is represented by this donut shape. In this scenario, we have four primary producers. Peter has apple, which has value, and he will give it to the system. In turn, the system will issue new currency, V, to Peter. Similarly, Mary has pears, and then she donates it to the system, and the system disperses a new currency to Mary. The same goes for Tina with her muddle bar, and for John with his sheep or meat. Now we have completed the disbursement of value. So what happens next? How we disperse value in the system? Let's say there's an electrician and Peter needs electric work done. He can hire that electrician and pay him with that currency that has been issued earlier. Similarly, if you have a plumber and Mary needs plumbing work done, then she can pay the plumber with that currency. Tina wants to buy a computer, she pays for it, and John wants to buy a car, he pays for it. Thus, we have started dispersing currency in this system. You have to keep in mind that the primary products, the apples, the pears, the metal bar, and the sheep, are all held in the system for the same exact value, for the same exact amount of currency that was disbursed to the primary producers. So what happens next? If the electrician wants to buy a metal bar, he'll buy it from the system, but the system does not need that currency because it already has served its purpose, so it eliminates it from the system. Similarly, if the plumber wants sheep, he can buy it from the system, and the system will eliminate the currency. And if the car manufacturer wants apples, he'll pay the system, and the system eliminates the currency. And if the computer manufacturer wants pears, then it pays with the currency, and then the system eliminates it. You may have noticed that we just created a system that bypasses barter trade, but leads more or less to a similar outcome. No currency exists when all transactions are completed. What we have accomplished so far is the following. We have determined the origin of value, how to disburse and disperse value in the form of currency V, but we still have to figure out how to determine the value of things, specifically of primary products. What is the value of any element, molecule, compound, or product? First, we will show you the periodic table of the elements and ask the following. Does aluminum have more value than iron? Does gold have more value than lithium? Does silicon have more value than uranium? Does oxygen have more value than carbon? It is difficult to answer any of these questions with any degree of certainty because each one of these elements possesses a unique value and unique attribute. What about molecules or compounds? How do we assess the value here? Consider the case of Peter, who has rice, and Mary, who has uranium. Value for their products can be determined objectively, subjectively, and relativistically, both in time and in location. There are two ways by which Peter and Mary can objectively assess the value of their product. The first objective way is by determining the hours of work needed to plant, harvest the rice, or to mine for uranium. The second objective way is by determining the usefulness of these two products in terms of the energy they can produce. Rice can provide energy to power humans, and uranium can provide energy for machines. Subjectively, they can assess value based on whether they like the taste or the texture of rice, or whether someone has allergy to it, or the concern for cancer if Peter decided to make a pot made of uranium to cook the rice. Relativistically, with respect to time, 200 years ago there was no value for uranium since there was no way to make good use of it. Relativistically, with respect to location, a small island with a small population, they cannot use uranium or need to use it, even in the present time. They do not need to make a nuclear bomb or nuclear power plants to power their island. This slide shows roughly the current prices in US dollars for different products. But where did these values come from? Let's simplify this slide and just show three products and make a comparison among them. Oil, for example, is used to power cars, trains, boats, planes, and heat your home. Uranium, on the other hand, 1 kilogram of it can produce 24 million kilowatt hours of energy, equivalent to burning 3 million kilograms of coal, and can power 6,666 average households for 1 year. Then why is gold almost 700 times more expensive than uranium? You cannot power anything with it, neither machine nor man. Why is one Bitcoin valued at $100,000? Because people are uncertain about value in general, and they try to find ways to protect whatever value they possess. They realize that our current monetary system is flawed at best, but they do not know what else to do. They're unable to value things reasonably or find a safe store of value. They do not have good alternatives. But our system of value will solve that problem. Back to our critical question, how do we determine value? We have to draw from the lessons we have learned in barter trade. In the example of Peter and John in an earlier slide, they both reach a consensus on value for two simple products, the apples and the oranges. In the example of Peter and Mary, they also reach a consensus on value of a simple product and a more complex product, the apple and the jam. In the example of Ford and the 4 suppliers for his car manufacturing, 5 people reach a consensus on value for many products to make a very complex product, the car. So the answer is clear. We have to reach a consensus on value to set an acceptable value for any primary product. And yes, we can reach that consensus on a global scale between thousands or millions of primary producers on millions of products. It's actually not that hard to do. Here's how it works. Consider primary product X. All primary producers will participate in a bid by offering a price for it and V, the unit for the universal currency. The automated system will accept only the bids which are equal to or less than the median price. We use the median instead of the mean because in a normal distribution, the mean equals the median, but in a skewed distribution, the median is less affected by extremes than the mean. Hence, the median is the most logical choice. In this example, the median was 7V. So all primary producers who offered a price of 7V or less will have their bid accepted, and they will all receive the median price 7V, not less if they offered less. They all receive 7V, and new currency will be disbursed to them for that amount. And those who offered a bid greater than 7V will have their offer rejected because they are either too greedy or inefficient. Because there are potentially hundreds or thousands of producers, then their competition should yield a reasonable cost for a product that represents its true value. However, the system will still set up an upper limit n to prevent any unusual or deliberate abuse. The SOV's upper limit on a primary product's value is part of the consensus mechanism because the operating body of the SOV, which we will discuss later, and who votes on that upper limit represents the vote of the entire human population, not just the primary producers. The consensus on value will be guided by the unit of account, which we will discuss shortly. Primary producers are guided by that unit of account, and the operating body for the SOV guarantees that guidance with its upper limit on value. The SOV will have a complete database of all primary products with their respective grades. The grade of a product is very important. For example, grade 1 rice will not participate in a bid with grade 3 rice because it would not be fair. They are two different products. Each primary producer will be able to sell and therefore how much V can he earn in a bid. We will later explain how the SOV determines what is the amount of material for any particular product in any particular bid. Until then, you should know that the total amount of the primary product that is needed is divided by the number of the producers who won the bid. For example, in Table 1, 6 primary producers won the bid. Therefore, you divide it 100% by 6, and that would be 16.6%. So each primary producer will be able to sell 16.6% of the amount needed. Let's take another example. So if you have 2,000 tons that are needed, and there are 200 producers who won the bid for a particular primary product, then each can sell 10 tons to the SOV and earn its value in D. Now we have reached the part where we have to define the unit of account for our universal currency. So what is 1V? A unit of account must be understandable. That is, most, if not all people, must understand what it means. It should also be relevant. Therefore, it should relate to something they need on a daily basis. So what is more relevant and understandable than saying that one unit of currency, V is equivalent to the energy needed to keep one human alive for 1 day. Meaning, if you earn 1 V per day, then you can stay alive for 1 day. This is a very easy concept for everyone to understand. We can say that 1 V is the cost of 1 kilogram of a theoretical product we call Brisev, which meets the specifications needed. In reality, however, we don't have exactly a primary product like the theoretical Brisev, but we have close enough products. Wheat, rice are such products where 1 kilogram of these products can provide the energy needed for one human for 1 to 2 days, depending on their physical characteristics and energy consumption. So 1 kilogram of wheat or rice serves an approximation to 1 kilogram of Brisev. It does not have to be a perfect equivalent. An approximation is good enough. Note that currently, wheat, rice, and maize constitute 2/3 of the total human food consumption. 1 V is divisible only into 10 equal parts. So every 10 small v's equals 1 V. So the value of any product can be 1 V, 2 V, 3 V, up to the n V. In the next few slides, we'll be using a few acronyms. So let's go ahead and define them. First, we have the EIT. This is the economy initiating transactions. So this is the first set of transactions when the SOV would become active. These are transactions that will create new money. This is where money is being disbursed with a B by the SOV. And then we have the EAT. This is similar to the EID. This is the economy augmenting transactions. It's just those happening after the initial set of transactions. That's why we refer to them as augmenting versus initiating transactions. And then we have regular transactions, RTs. These are transactions between any person or entity when they are paying each other, but that does not involve any new money creation. It's just dispersing with a P the money that's already created in an EIT or EAT. And finally, we have the terminating transactions. These are transactions that eliminate consumed value, that it is removing the money from the SOV because that money has served its purpose. This will happen when consumers actually buy the primary products, which the SOV created new money for through the bidding process discussed earlier. This table shows us how money circulates in the economy and is eventually eliminated from circulation once primary products are consumed. You can see that in transaction number 1, which is an EIT, economy initiating transaction, new money was disbursed for the amount of 100 Vs to the farmer. Then in transaction number 2, which is now a regular transaction, the farmer is spending the money in the circulation. So he paid the gas station 20 Vs. In transaction number 3, he paid the plumber 10 Vs. In transaction number 4, he paid the dentist 30 Vs. And in transaction number 5, he paid the school 40 Vs. In transaction number 6, the school paid the plumber 20 Vs. In transaction number 7, the gas station paid the plumber 20 Vs. And in transaction number 8, the plumber paid the dentist 50 Vs. And in transaction number 9, the dentist paid the school 100 V. And in transaction number 10, the school paid its teachers 100 V. If you notice that so far in all these transactions, the balance at the end, at the bottom here, is always 100 V. So what happens at transaction number 11? Why is the balance 0? Because this is a terminating transaction, meaning primary products have been sold from the SOV. So let's say all these teachers decided to buy wheat and they bought it from farmer number 1. And once they actually bought this primary product, the system will remove the V's from circulation because they already served their purpose. This table is yet another example of how the money would circulate in the economy. You can see that in transaction number 1, it's an economy augmenting transaction where new money was created. So the SOV disbursed 100 V's to the uranium producer. In transaction number 2, the uranium producer paid 40 V's to the mine workers. In transaction number 3, he paid 30 V's to buy some heavy machinery. And in transaction number 4, he paid the government 30 V's. You could call this taxes, or more appropriately, he paid the government for the services that the government provided to him. The government here really acts as a service provider. In transaction number 5, the mine workers also paid the government 20 Vs. In transaction number 6, the mine workers paid the nuclear power plant for the energy it provided to their houses. In transaction number 7, the heavy machine operator paid also the nuclear power plant to run his factory. And then what happens in transaction number 8 and 9, these are terminating transactions. So in transaction number 8, you can see here that the government lost those 50 Vs, or 50 Vs were eliminated. Why? Because obviously the government actually bought the uranium that's in the SOV. So once it bought them from the system eliminates the currency. And then in transaction number 9, another 50 was eliminated because now the nuclear power plant bought the uranium from the SOV and the currency was eliminated. Let's summarize what we have learned so far about our system of value. In the SOV, primary production is the ultimate source of all value. That is why currency issuance is based solely on primary production. Currency from primary production is transferred to every sector in the economy, and consensus on value is what determines value. Every V created and destroyed is accounted for in real time in the SOV. It is the universal instantaneous digital ledger. Every entity registered in the SOV has an account number, whether it is a person, an organization, or a government. In addition, primary producers will have a special product numbers linked to their account to generate an identity for every unique V created. Every new V created is tagged to the account of the primary producer and to the particular primary product that it was created from. For example, if the account number here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and if the primary product number that caused the creation of those V's is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then the specifier is 931. Now the unit here could be different for different products, but let's say the unit here is 1 kilogram of apples, and if 1 kilogram of apple is worth 0.5 V or 5 small V's, so you can see here 1, 2, 3, 4, 5 for the first unit, and then 1, 2, 3, 4, 5 for the second unit. So that particular primary producer, if he sold those 2 units, he would be earning 10 small V's or 1 big V. So here you can see the V's being produced in chronological order, assuming this is the first V ever created in the system, and then we go forward in time. So in this example, this particular product is the first product that earned new V's in the system. So the unique ID for V would be the chronological order of V's, followed by the account number of that primary producer, followed by the product ID, and then the unit number for that product. An important feature of the SOV is that a primary producer cannot participate in an EAT until 50% of what he supplied in the previous EAT or EIT is sold in the SOV. If a primary producer is not selling his product, then he cannot keep participating in an EATs and earn new money without selling anything. You cannot reward someone just for producing. He has to be selling what he produces. He has to sell at least 50% of the primary product that earned him the new money in a previous EAT so that the SOV would allow him to participate again in a new EAT. Note that all primary products are essential products and will be consumed, so they will all sell. We'll have more to talk about this issue in future slides. What this table shows us are different primary producers. We have primary producer number 1, primary producer number 2, and primary producer number 3. We gave examples of primary producer 1 having 1, 2, 3 products, and then primary producer number 2, 1 product, and primary producer number 3, 1 product. So if primary producer number 1 earned 20 V's for primary product number 1, and he sold what is worth 11 V's, which means he sold more than 50% of that particular product, then he can participate in EAT. Note that I use product and V's interchangeably because if the V's are removed from the system, it means that the product is actually sold. For product number 2, he cannot participate in EAT because less than 50% is sold. And for product number 3, he can participate because more than 50% are sold. As for prime producer number 2 and his product, he could not participate because he barely sold anything. And prime producer number 3 for his product, he can participate in EAT because he sold 50% of that product. So how much of each primary product will the SOV accept? How will the EIT or EAT be initiated? Well, it's simple. Just find out what is the normal annual demand for the primary product. But what is normal? For the time being, we will say that normal is the actual current annual consumption. This table shows close enough numbers to the real current annual consumption. The SOV will always maintain the supply of primary products at the annual global consumption value. So whenever that amount goes below that value, then automatically and instantaneously an EAT is triggered by the system to replenish that product and restore it to its baseline value. And new money will be created as a result of such EATs, which would replace the consumed or eliminated money. So in this table, if no one is buying natural latex or titanium, then no EAT will be triggered. But for the rest of the products, so for wheat, iron, and natural gas, EATs will be triggered to restore their amount back to the value of AGC. This mechanism will have extremely important consequences, as we will explain shortly. Note that the money supply can be controlled by what value set for the AGC. Also note that the money supply is determined by the economy of production, by the production of real value. It is not created by central banks, private banks, crypto miners, or by Augustus Caesar. The mechanism presented here kills two birds in one stone. One, we are maintaining adequate product supply, and two, we are creating money at the same time. So what is the total amount of the currency V that can be generated in the economy? If you recall, AGC is the annual global consumption. The ACP is the annual currency production, which is the value of AGC. The total products consumed annually, the AGC, is equal to the sum of the individual products consumed, P1 plus P2, and so on. The value of the total products consumed annually, the ACP, is the same as the total amount of currency produced, V total, which is the sum of the amount of all products multiplied by their value, N. So P1 times N1 plus P2 times N2, and so on. To give you an idea of how much money can be generated from food production alone, assume P1 represents all food products combined, and N1 is their value in V. If you recall from the definition of the unit of account, we need 1 V to keep one human being alive at minimum. So multiply that by the days of the year, then multiply that by the number of people on the planet, which is 8 billion. So you end up with about 3 trillion Vs generated annually from food production alone at minimum. What would the quantity theory of money predict would happen if our currency creation model is applied? QTM can be represented by the equation mv equal py, where m is the money supply, v is the velocity of money, or how often money circulates or changes hands. To distinguish this from our unit of currency, v was double strike through, p is the price level, and y is the real output, which is the final goods and services produced in the economy. QTM assumes that v and y are constant. So here we just replaced the v with k1 and y with k2 to signify that they are constants. In the SOV, the money supply equals the total amount of currency produced, v total, which is equal to the ACP, the annual currency production. The annual currency production is the value of the AGC, the annual global consumption, as we mentioned in previous slides. But AGC is almost constant, and the value of the individual components of the AGC are also expected to be relatively constant given the two levels of moderation it is subjected to. One being the median cost rule used in the bids for primary products, and two is the upper limit N on primary products guided by the definition of the unit of account. So if the ACP is relatively constant and V and Y are constant, then the price should remain constant. So now we represent the money supply with K3 to show that P must be also constant. Let's consider a scenario where Y is not constant. So if the money supply is constant but Y increases, that is, more final goods and services are produced in the economy, then the prices should fall. But the SOV has a mechanism that can mitigate that. The ACP can be increased by increasing the set value for the AGC. So we go above the baseline for the AGC. That is, we allow more primary products to be accepted by the SOV in a year. So really, this is a little bit more than the annual global consumption. You can call this AGC plus. However, Y is hard to increase due to the 1-year limitation on the primary products that Y is made of. What if the opposite happens? What if Y decreases? That is, the final output shrinks. Then P, the prices are expected to increase. Well, in a similar fashion, if Y decreases, then the ACP can be decreased in proportion to that by decreasing the set value for the AGC. That is, we allow less primary products to be accepted by the SOV, so less than the baseline of the annual global consumption. You can call this AGC minus. Now let's consider a situation where the velocity of money is not constant. So if the money supply is constant but the velocity increases, that is, money circulates faster, then the prices are expected to rise. So the ACP in this case can be decreased by decreasing the set value for AGC. And if the opposite happens, that is, the velocity decreases, money circulates slower, then the prices are expected to decrease. So the ACP here can be increased proportionally by increasing the set value for the AGC. In the SOV, at baseline, the annual global production is the same thing as the annual global consumption. So how much do we need to adjust the annual global production to affect the annual currency production? If there is a need to do so for some reason, as we suggested in the previous slides. For simplification purposes, we're going to assume that the daily currency production is about 100 billion Vs, 8 billion Vs for food production, and the remaining 92 billion from other primary production sectors. If we allow 10 extra days of primary products to enter the SOV, or 10 less days from the baseline of 365 days, this will result in an increase or decrease in the annual currency production by 2.7%. In table 9.2, we made the change to be 20 days, and this will give us 5.6% increase or decrease in the currency production annually. And in table 9.3, we made the change to be 30 days from baseline, and this will give us an increase or decrease of 8.5% in the currency production. So allowing 30 days more or 30 days less of primary products to enter the SOV will increase or decrease the annual currency production by a significant amount. So how would the supply and demand curves look like in the SOV? On the vertical axis, we have the prices, and on the horizontal axis, we have the supply quantity. As expected, as the prices increase, the supply quantity increases, so the sellers will make more money, and as the prices decreases, the supply quantity decreases. But in the previous slides, we learned that in the SOV, the price is relatively constant. So that blue line is much narrower in the SOV and is represented by the yellow line. The demand curve will show us something similar. As the prices decrease, the demand quantity increases, since things are cheaper and people buy more. And as the prices increases, the demand quantity decreases. But because the money supply is relatively constant in the SOV, then the prices are relatively constant, and then this red line will shrink to this green line. Superimpose the supply and demand curves over each other, we get this graph. You can see that at this point, the quantity demand equals to the quantity supply, which is known as the equilibrium quantity, which would occur at the equilibrium price. But in the SOV, because the money supply is relatively constant and the prices are relatively constant, then you'll have supply and demand that are nearly matched, and we will be already at the equilibrium point and remain at the equilibrium point. This brings us to the following question. What is the normal annual global consumption? What about the current annual global consumption? Is this normal? If you think it is normal, then the current consumption is the normal annual consumption. But is current consumption sustainable? Does it promote planet stewardship? If the answer is yes, then start with it as a baseline for normal. And if you think it's unsustainable, then decrease it. Or if you think it is insufficient, then increase it. What about savings? How can you save money in the SOV? Well, if production equals consumption, then you will have no savings. If production is greater than consumption, then you can have savings. And if consumption is greater than production, then you'll be in debt. Remember that the SOV is a production-based economy. It's not a finance-based economy. You can only save from making real things. Note that the only natural and logical way of savings is from overproduction. So how much can you save from production? 1 year extra, 2 years, 3 years, 10 years extra? Note that if you do not overproduce but yet you save, then someone is your slave. Let's take a closer look at savings in numbers to keep things in perspective. Table 10.1, just like Table 9.1, assumes a baseline daily currency production of 100 billion Vs. So these are 100 billion Vs that are created every day but also consumed every day and thus eliminated from circulation. However, if you recall, the SOV allows 1 year worth of primary products to be available at all times. This will translate into about 364 days of money that is not consumed and remains available. That is the natural amount of savings that are possible from production or overproduction. These are real savings, not fake savings. If you assume that all 8 billion people on this planet are saving equally, that is, if you divide the total savings, which is about 36.4 trillion Vs, divided by 8 billion people, this will give you 4,553 Vs of savings per person. So what would that amount of savings do? This will be enough money for one person to eat for about 12.4 years. Now, table 10.2 shows us what happens when you increase the daily currency production to 200 billion Vs. So this is worth of 2 years of primary products being accepted by the SOV. This will increase the savings per person if every person, again, is saving equally on the planet. And that will also increase the amount of years that will feed them up to 24.9 years. And if you increase the daily currency production to 300 billion Vs, then each person can theoretically save enough money to eat for 37.4 years. Again, we are assuming here that the savings are equal among all 8 billion people on the planet. But in reality, some people may be able to save more, or some people may be able to save less. Currently, in some countries, there are no savings at all. And in some countries, people have too much savings. So who is in charge of the SOV? Who is the operating body? It is the Universal Currency Organization, which shall be created. The UCO shall represent all countries in the world. So if we assume there are 195 countries in the world, then each country will have a representative that will participate in the election of the 7-member board of trustees of the UCO. It's up to each country individually to decide how they want to elect their representative. Their government can select someone or their people can elect someone. It's up to them. But once we have those 195 representatives from each country, then they will meet and elect 7 members to serve as the Board of Trustees of the UCO. Each representative from each country will have a weighted impact based on the population of his country. So in Table 11, instead of putting all 195 countries, we just selected 5 countries for simplicity. So you see here that Nigeria, for example, and Canada, which are represented in pink, they both selected the Nigerian representative. So you add each country's population, so in this case 2 plus 3, and you'll end up with the 278 million people or votes. Whereas Switzerland, Nepal, and Brazil, which are highlighted in light green, their added population will yield 256 million votes. So in this case, the Nigerian representative will win a seat on the UCO Board of Trustees. Note that each country can select only one UCO board member. And the first 7 that win are the ones who have the highest total vote. This way, even if you have one country with a very large population, it can only affect the election of one board member. You still have 6 more. Consider 2 large countries, each one with 1.5 billion people. If they both vote together, they get 3 billion people. But in that case, they can only elect one person. So this system is very democratic and very fair. All countries are represented. They get to select their own representative, and they participate in the election of the board based on their population, and the first 7 wins. So how can we transition from our current system of currencies to a system of value, our system of value, exclusively? Well, producers can gradually cease utilizing fiat currencies over a period of 5 years. Any producer in the first year of transition can allocate 20% of their production to be sold in V's only, and the rest in other currencies that they usually use. They can increase their allocation of sales in V annually by 20% until the 5th year, when 100% of sales would be in V. Let's recall a few concepts that we encountered earlier in this presentation. An economic system exists because of the energy used to perform work in that system. So if we all sit down here on our chairs watching YouTube videos and do nothing else for a year, there will be no economy since no energy is spent to do useful work. We quantify our energy that is used to produce useful work in terms of money or currency, and we circulate it among us. In our system of value, the energy we spent has a value, V, which you quantify in terms of money, and in the SOV, currency is equal to money. Money and currency are the same things, unlike what we have under our current monetary system. And the currency is N times V, which are the number of V's produced from real production, which is effectively the energy that the human population as a whole produced in the economy. In this slide, we'll discuss a few ideas that are worth thinking about. First, the global debt, which is borrowing by governments, businesses, and people, is steadily increasing and reached 307 trillion US dollars in 2023. What does that mean? The fact that global debt is steadily increasing over the years suggests it's not going to be paid back. It also means that a lot of people did a lot of work and were paid with money that does not really exist, since it does not represent real value. It is created out of debt that will not be paid back. Isn't this how you trick people into economic slavery? The second point is, what's the global GDP in the SOV? And the answer is simple. It is the annual currency production, which is easily and automatically measured by the system. And unlike the GDP, the real ACP
is the same thing as the nominal ACP, as there's no expected inflation. The SOV will have complete economic data in real time. Every metric you can think of is measured and displayed for the entire human population to see and analyze in real time with tables and graphs. It's a fully transparent system. What about economic visibility of a product? So if any product cannot produce 1V per day per person, then its production cannot even feed one person. Hence, it's not economically feasible to produce it. So where do we go next? We have created the SOV on paper, but it's probably useful to create a computer simulation of this model and see how it behaves. And if the result is satisfactory, then we go ahead and create the Veconomy app or VAP. This will conclude the second and last part of our presentation. If you have not watched part 1, please consider watching it. If you like the ideas that were discussed, then please spread the message. Tell your family, friends, and colleagues about this presentation. You can write comments on your social media or your blog. Please consider reading the book, which has much more details than we presented here. You can write reviews on Amazon or any other site. So thank you and welcome to Value-Based Economics.